So, you're a data science grad, you're looking for your first big job in Microsoft Fabric, and you've got a technical interview looming. Yeah, it can be pretty intimidating. But we're here to help. In this explainer, we are going to break down everything you absolutely need to know about Dataflow Gen 2 so you can walk in there and impress even the most senior architect. Let's get right into it. Our whole goal here is to get you so prepared that you can walk into that interview and not just answer the tough questions, but actually feel confident doing it. We want you ready for any curveball a senior enterprise architect might throw at you. Think of this as your secret weapon for that interview. Now, we've broken this down into two key parts. First, we're going to cover the theory, the big architectural ideas, the what and the why. Then, to make it all real, our expert Rajan is going to jump in and give you a full hands-on demo. So you'll get the concepts with me, and then you'll see exactly how they work in practice with him. Here is our roadmap for today. We'll start with the absolute essentials of the build process. But then, we're going to ramp up fast into the topics that really matter in an enterprise interview. How to scale for huge datasets, how to keep costs down, and how to make this stuff work in a real automated workflow. This is basically your study guide. Okay, first things first. Before we can even talk about the high-level architecture, you have to nail the fundamentals. So let's do a quick run-through of the core process for building a Dataflow Gen 2. At its heart, it really just comes down to these 4 steps. You connect to your data source, you use the Power Query editor to transform it, you pick a destination, like a Fabric Lakehouse, and then you publish it and set up a schedule. Simple enough, right? This is your foundation. Now, let's get into the questions that are really going to make you stand out. And here we go. This is probably the most critical question in any data engineering interview. Performance. How do you make sure your solution doesn't just work, but that it's fast and can handle massive scale? So imagine this. You've just shown off your proof of concept. It works great. Then the architect leans back and asks this question. This is cute, but how do you make it handle terabytes of data? This is your moment to shine. And your answer isn't about a single feature. It's about having a clear strategy that changes based on the workload. This right here, this table lays out your strategic playbook. You've got 3 main tools in your toolbox: fast copy, the modern evaluator, and partitioned compute. The real skill is knowing exactly when to pull out each tool. It's all about picking the right approach for the right job. Let's talk strategy number 1. If your main goal is just to move a massive amount of data from point A to point B with very little transformation along the way, you go with fast copy. Seriously, think of it like a dedicated freight train. It bypasses all the small local stops and just barrels down a dedicated track to get your data where it needs to go fast. And the proof is in the numbers, right? I mean, look at this benchmark. A job that took over an hour to ingest data now takes less than 8 minutes. That's almost a 9x performance improvement. These are the kinds of concrete results that make an enterprise architect sit up and pay attention. But what if you're not just moving data? What if you have to do some really heavy lifting, complex joins, cleaning, aggregations, all happening across hundreds of massive files? Well, that's when you bring out the big guns. You combine partition compute with the modern evaluator. And the results here are just staggering. We're talking about taking a process that took an hour and 45 minutes and getting it done in under 5 minutes. That is a 22x speed increase. This isn't just a little bit better, it is a total game changer for large-scale data prep. This is how you confidently say, yes, I can handle terabytes of data. Okay, so you've proven you can make it fast, but a good architect cares about more than just speed. They care about the bottom line. Can you make your solution efficient and cost-effective? This is the follow-up question that really separates the coders from the architects. It tests your business sense. See, scalability isn't just about raw speed. It's about being able to perform sustainably without bankrupting the company. Your first and best answer here is incremental refresh. This is such a key concept. Instead of wastefully reprocessing your entire multi-terabyte dataset every single time, this technique is smart. It only processes the data that's actually new or has changed. It is the absolute definition of working smarter, not harder. So how does it actually work? Well, behind the scenes, the Dataflow splits your data into these logical, time-based chunks or partitions. Every time it runs, it just does a quick check to see which partitions have new data, and it only processes those. All that older, historical data, it's left completely untouched. This saves a massive amount of time and, more importantly, compute resources. The other part of your cost efficiency story is understanding how the billing actually works. In Fabric, different operations consume what are called capacity units, or CUs, at very different rates. And as you can see, something like fast copy is literally 10 times cheaper per second than the standard compute engine. So choosing the right tool for the job has a direct and huge impact on the final bill. A data flow almost never lives on an island by itself. A really good architect knows how it fits into the rest of the company's systems. So let's talk about how Dataflow Gen 2 plays with others in the bigger picture. First off, you need to know where you can send your process data. Dataflow Gen 2 is super flexible. It can write to all the core Fabric services like the Lakehouse and Warehouse, but it can also push data to external places like Azure SQL. This flexibility is absolutely key for enterprise integration. And when you're loading that data, you have a classic architectural decision to make. Do you replace or append? Replace is basically a full wipe and load. It's clean and simple. Append, on the other hand, adds new data on top of what's already there, which is perfect for building up historical data over time. Knowing which one to use and why is a core skill. And here's a really crucial point. In the real world, you don't just log in and click run on a data flow. No way! They're almost always just one step inside a larger Fabric pipeline. This is what allows you to build complex workflows with dependencies, proper scheduling, and end-to-end orchestration. And if you really want to show your thinking at an enterprise level, you have to talk about APIs. This shows you're thinking about DevOps and CI/CD pipelines. You can use APIs to completely automate your deployments, to build custom monitoring and alerting, and even to implement your own sophisticated error handling. This is the stuff senior architects really care about. All right, we have covered a ton of ground. Before I hand things over to Rajan for the hands-on demo, let's just boil all of this down into a final checklist you can take into your interview. This is it, your 5-point cheat sheet. If you can speak confidently about these 5 areas, you are going to be in fantastic shape. Know your scaling strategy, your efficiency tactics, the cost levers, your destination choices, and the whole integration and automation story. So now you have that solid theoretical foundation to back up all your skills. You get the architecture, you understand the trade-offs, and you're thinking about the big picture. You are absolutely ready to see this in action. Rajan, go ahead. You may now proceed with the demo.
Hi guys, so right now I'm logged into my Microsoft Fabric and I'm in my workspace Toronto, and this is my Lakehouse page Toronto. So to demo the Dataflow Gen 2, how we can create it. So once we are in the Lakehouse, we can click here on the Get Data. Then we can select this new Dataflow Gen 2. Give it some name, for example Dataflow 2 here. Enable Git integration development pipelines in public API scenarios. So check mark this one, create. So it gives us this page, and here we can import the data from SQL Server, that's our destination is Lakehouse. Import from CSV, import from data flows. So here we can select whichever is our source is. Right now my source is CSV file, so I click this one, and all these connections and everything I have filled up, and then I click next. It will bring in the data. So right now I'm not doing this one, I already did it here. So in here, once it brings the data in the data flow, you can see this one. And this is our familiar Power Query in Power BI. So this is our no code, low code ETL. can do it here. Like we can add some columns, or we can remove some columns, or like whatever we want to do here. Let's say we remove this column here, month number. So here it writes all the steps, same as Power Query. There is no difference here. The difference architecture wise is a little bit bigger, because here we are uh, running this as a part of Microsoft Fabric, which is a SaaS offering. So this one runs on a very powerful backend like Microsoft Fabric system. Huge connectivity to many sources. So this is, but otherwise this is the interface is very same as Power Query. This is Power Query actually running in the cloud. So here we will have like many data queries as well. We build many sources, we can have many sources. We can also do the merge queries, create new queries after the merging. So all these operations, regular operations in ETL, which we can do it all here. Other than that, we have the diagram view here. So one is these steps that are written here. The same steps here are displayed as a nice graphical way. So we can see, right, first connecting to the source, then promoted headers, then change the columns, then added column, then we remove the columns. All these steps are written here. So this is a nice lineage. We can see where the data is coming from and how it is transformed. And if you are familiar with SSIS or Informatica or some other ETL tools, you will know these steps, how they display it and how this is doing here. So once this is done, we save the data flow and run the data flow, which will basically bring in the data in the lakehouse. This is our lakehouse default destination. It's defined like this. So after that, we can create a pipeline. We can run the data flow from the pipeline. So like once we create a new pipeline, something like once we are here, we can see a new pipeline, give it a name, and then this is a default copy activity. It is opening. So if we don't require doing any copy, because we are doing this with Dataflow Gen 2, so we can cancel this. And instead of that, we can just once we are in the pipeline, we can just say Dataflow. It gives us this. Here we can do the settings. In the settings, we can select our data flow, and then we can run the data flow. We can save the pipeline, and then we can run it. So I already did it here. So once we run the pipeline, we can see the status here. Data flow activity status succeeded. Once it succeeds, we can see that in the workspace, we can see in the workspace the Dataflow 1, Dataflow 2, I created it a couple of times. But here is the pipeline. Pipeline it will show us the status. Pipeline run ID is this status, and it shows the input and output. This was a quick overview of how we see the data flow, how it is created, and how it is run through the pipeline. Thank you.
Welcome back to the deep dive. Today we're doing something a little bit different.
We are.
We have a very specific mission, and we're talking directly to a very specific group of people.
That's right.
What?
We're looking at you, the learner, specifically the fresh data science graduates out there.
Yeah.
You've got your degree, you know your Python, you can probably wrangle a pandas data frame in your sleep, but now you're staring down the barrel of the real world.
The dreaded technical interview.
Exactly. And, not just any interview, not the write a bubble sort of on a whiteboard kind.
No.
We're talking about the hour-long grilling with an enterprise solution architect.
Oof.
The person who, frankly, doesn't care if your code is elegant. They care if it's going to crash the server, leak data, or, cost the company a fortune.
It's such a terrifying shift, isn't it? You go from academia, where the entire goal is get the right answer,
Right.
to the enterprise, where the goal is build a sustainable, reliable, and cost-effective system.
A completely different mindset. And today, we're going to help you ace that interview, specifically when it comes to Microsoft Fabric Dataflow Gen 2.
This is really going to be your cheat sheet.
It is. We're going to take you from that surface level, I know how to click the buttons knowledge,
Which is where most people stop.
all the way to I understand the engine architecture, the cost implications, and the optimization strategies.
Before we really dive in, though, we have to give a massive, massive shout out to Rajan.
Absolutely, we have to.
Rajan provided this incredible hands-on demo that really, it sparked this entire deep dive.
It's a perfect foundation, a really solid walkthrough.
So just to recap what Rajan showed us, because it's the baseline we're building on today, he walked through the Fabric sauce web interface. He built a Dataflow Gen 2 completely from scratch. He grabbed some data from GitHub using an HTTP source.
Which is a classic hello world for data engineering, right?
Totally. It's the standard starting point.
Get some data from a URL.
Then he did the ETL magic, all inside the Power Query interface, filtering rows, changing data types, the usual stuff.
To clean up.
And then the final step, he executed that data flow through a pipeline to create Delta tables. It was a beautiful, clean, happy path demonstration.
It was. And look, here's the harsh truth for you.
Okay.
If you go into that interview with a solution architect, and all you can do is recite those steps,
You're in trouble.
you're probably not getting the job.
Ouch. Okay, so unpack that. Why?
Because the architect already knows that clicking the buttons is the easy part. Any junior developer, any intern can follow a tutorial.
Right.
The architect is looking for the person who knows what happens when you click the button.
They weren't the why.
They want the why. They
Yeah.
want to know if you understand the hidden costs, the performance bottlenecks, the security nightmares that are, lurking just behind that clean, friendly user interface.
So that's our agenda. We are taking Rajan's practical demo, and we're layering on the deep, the gritty, the architectural knowledge,
We're going to talk about the things that break, the things that cost money.
and the things that make security teams scream.
Oh, yeah. We're going to cover the core architecture, the ingestion strategies that separate the pros from the amateurs, advanced optimization techniques, and maybe most importantly, the network plumbing.
Okay, let's start at the beginning, the absolute core. What actually is Dataflow Gen 2, if that's the first question in the interview?
Right. At a surface level, if you ask a casual user, they'll say something like, oh, it's Power Query in the cloud.
And it looks like that. It looks like Excel. It's like Power BI desktop.
It's that same friendly, low-code environment where you can click around and transform data. It feels familiar.
And that familiarity is almost a trap, isn't it?
It is absolutely a trap because while the interface looks and feels like the Power Query you've used on your laptop for the last 5 years, the infrastructure underneath it in Fabric is a completely different beast.
Let's talk about that infrastructure, because when I click New Dataflow Gen 2 in my workspace, I'm assuming I'm just creating a script, like a text file with some M code in it.
And that's what it feels like.
But Fabric is doing something massive in the background.
It's provisioning an entire environment for you. When you create that first data flow in a workspace, Fabric automatically and quietly sets up a lakehouse and a warehouse specifically for that data flow's use.
Wait, so every time I make a new data flow, I'm spawning a whole lakehouse.
Effectively, yes, for the workspace. The first one creates these shared staging environments. And you might have noticed these artifacts popping up in your workspace list.
Oh, yeah?
They usually have names, starting with something like data flow staging.
I have definitely seen those. And I have to be honest, my first instinct is always to delete them.
Everyone says.
They look like clutter.
Yeah.
I'm trying to keep my workspace clean, and I see Dataflow Staging Warehouse 1, and I think, I didn't make this, it's junk. Let's trash it.
Do not do that.
Yep.
I can't stress this enough. That is rule number 1 for your interview. If the architect asks, how do you manage workspace clutter? The absolute wrong answer is, I delete the staging artifacts.
Why? What actually happens if I delete them? What breaks?
So you break the entire plumbing. Those items are not just temp files. They are the engine room for all your data flows in that workspace.
So they're shared.
They're shared by all of them. And even though they're visible, and you can technically query them via the SQL Analytics endpoint or from a notebook, they are managed by the system.
I see.
If you delete them, your data flows lose their ability to stage data, and everything, and I mean everything, grinds to a halt.
Okay, so they're the do not touch zone, but why are they even there? What is the system actually doing with this lakehouse and warehouse?
This brings us to probably the most critical concept for an architect to understand. It's the tale of two engines.
2 engines? I thought it was just Power Query.
See, that's the trap. Fabric Dataflow Gen 2 uses 2 completely different compute engines to process your data. You have the standard compute, which we call the mashup engine, and then you have the high-scale compute, which is the SQL engine.
All right, let's break these down. The mashup engine, that's the classic one, right? The one we've known for years.
Correct. That's the engine that's inside Power BI Desktop. That's what interprets your M code.
And it's good at what it does.
It's fantastic for complex logic, custom functions, parsing weird JSON files that aren't structured well. But think of it like a very smart, very capable food truck.
Okay, I like that analogy.
It can make gourmet food, but it can't feed an army of 10,000 people in 10 minutes.
Because it's processing things largely in memory, right, on a single node.
Exactly. It's resource constrained by design.
In the SQL engine, what's its deal?
The SQL engine is the industrial factory. It's a massive distributed SQL backend. When staging is enabled, and this is where those data flow staging artifacts come in, Fabric tries to offload all the heavy lifting to that powerful SQL engine.
So it's about pushing the work down to the right tool for the job.
Precise.
So if I'm an architect interviewing you, a candidate, I don't just want to know what you did. I want to know if you understand where your query is actually running.
Exactly. I want to know, are you running this transformation in the memory of the little food truck, the mashup engine? Or did you structure your query in a way that pushes the logic down to the industrial factory, the SQL engine, for massive scale?
And that single decision.
That decision determines whether your data refresh takes 2 hours or 2 minutes.
Wow, okay. This feels like a perfect transition to the biggest bottleneck in all of data engineering, getting the data in the door.
Ingestion is where most junior engineers fall down. Rajan showed us pulling from GitHub via HTTP. And that works great for a few megabytes, a CSV file, whatever.
Sure.
But in the enterprise, we're not talking megabytes. We're talking terabytes.
Yeah.
We're talking about the drinking from a fire hose problem.
So if I try to pull a terabyte of data, or even just say 100 million rows from a database using that standard mashup engine logic, what happens?
It's like trying to move a house by carrying it brick by brick in a wheelbarrow.
I'll get there.
It works, eventually. Yeah. But it's agonizingly slow, and you're paying for every second of that slowness. The mashup engine has to read the data, interpret it, process it row by row in memory. It's just not built for bulk movement.
So what's the solution? How do we get the big truck? How do we stop using the wheelbarrow?
The solution is a feature, a very specific feature called fast copy.
Fast copy. Okay, you said it earlier. It sounds like a marketing buzzword, like turbo mode.
It does sound like one, but it's actually a distinct architectural switch. When fast copy engages, Fabric literally swaps out the back-end engine.
Swaps it out.
It stops using the mashup engine for ingestion, and it switches to the pipeline copy activity backend.
Wait, so it becomes Azure Data Factory under the hood?
Exactly that. For that specific step, you are running ADF. It uses the same highly optimized, parallelized bulk loader technology that powers the copy activity in ADF pipelines.
That's a great analogy. It's like putting a Ferrari engine inside a Honda Civic.
That's perfect. The user still sees the friendly Power Query interface, the Civic's dashboard, but under the hood, for that one task, it's a race car.
But I assume there are rules. I can't just use the Ferrari for everything, right? I can't take it off-roading.
Right. You can't drive a Ferrari to pick up groceries efficiently. Fast copy has thresholds. It won't kick in unless the job is big enough to justify the overhead of spinning up that powerful engine.
What are those thresholds? This feels like perfect interview trivia, something that shows you know the details.
It is. This is a great detail to drop. If you're dealing with files like CSVs or Parquet files sitting in a data lake, the file needs to be at least 100 megabytes.
100 megabytes. So if I have a 50 megabyte file, Fabric just says, nope, not worth it, and uses the standard engine.
Correct. It'll use a wheelbarrow because it's faster for a small job.
Okay. And what about for databases? Let's say I'm pulling from an Azure SQL database.
The magic number there is usually around 5 million rows. It can vary a little based on complexity, but that's the general rule of thumb. If you're pulling less than that, you're likely getting the standard engine.
Is there a way for me to know for sure, like, can I see it? Or can I force it?
You can, and this is a fantastic debugging tool. In the query options, for a specific source, you can select Require Fast Copy.
What does that do?
It forces the engine to try. But here's why it's a great tool. If you check that box and your query isn't actually compatible with fast copy,
It fails.
the refresh will fail immediately. It gives you a clear error that basically says, hey, you trying to do something that the Ferrari can't handle.
Okay, so what can't the Ferrari handle? What are the limitations?
This is the catch. This is the big trade-off. Fast copy is a brute force mover. It is not a nuanced thinker.
It's all muscle.
All muscle, no fine motor skills. It supports very, very few transformations. It can combine files. It can select columns. It can rename columns. It can change data types. And that is about it.
So no group by, no joins, no complex conditional columns.
Absolutely not. If you try to ingest a billion rows and do a group by in that same query step, fast copy shuts off.
It just disengages.
It falls back to the slow engine, the mashup engine, because the copy activity backend doesn't know how to group data. It only knows how to move it.
This seems like a paradox. We need to move the data fast, but we almost always need to transform it. So how do we solve this? How do we get both?
This leads us to the single most important design pattern you need to talk about in your interview. It's called the split query pattern. Some people call it the ingest then transform pattern.
Walk us through this. This feels like the aha moment for a lot of people.
Okay, so imagine you have a massive data set you need to process. Step one, you create a query. Let's call it query A.
Okay.
This is your ingesting query. You use fast copy here. You do nothing complex. You just point to the source, maybe you select only the columns you need, and you dump it directly into staging.
So query A is just a dumb pipe, a big, fast, dumb pipe. Get it in the door.
Exactly. Get it onto the platform. Now, that raw data is sitting in the Fabric Lakehouse, that Dataflow staging artifact we talked about at the beginning.
Right, the engine room.
Exactly. Now, for step two, you create a second query, query B. This is your transformation query.
And its sources.
Its source is query A. You're reading from the data that's already been staged. And because that data is now sitting in the SQL backend, query B can use the high-scale SQL compute engine to do all the heavy lifting.
I see it now. So query B is where you do your joins, your group bys, your complex aggregations, all that logic.
Yes.
Yeah.
Because the data is already on the SQL storage, the SQL engine can roar to life and crunch those numbers using its full distributed computing power. You have successfully separated the move from the transform.
And there are visual indicators for this, right? If I'm looking at my screen in the Power Query editor, how do I know I've done it right?
Yep, there are a couple of clues. In the step editor pane on the right, look for the icons next to your steps. You want to see lightning bolts.
Lightning bolts.
A green lightning bolt means fast copy is active and working. If you see a red one or it disappears, you've added a step that broke it.
And the other clue.
In the refresh history for the data flow, you can literally see the engine type listed for each query. For that first query, for query A, you want to see it say copy activity. That's your proof.
Let's talk numbers, because architects love benchmarks, so they want quantifiable proof. Our research mentioned a test case using the NYC taxi data set.
Ah, yes, the gold standard for big data testing. Billions of rows of taxi rides.
It's massive.
It is. And the results from testing this pattern were frankly, shocking.
Ow, shocking.
Okay, so when the team tried to ingest and process this data without fast copy, just, standard Power Query logic in one big query, it took about 1 hour and 9 minutes to run.
Okay, 1 hour and 9 minutes. That's a pretty long coffee break.
Then they switched to the split query pattern with fast copy. Any guesses?
20 minutes.
7 minutes.
Whoa. From over an hour down to 7 minutes.
That is, almost a 10 times faster results, a 9x improvement?
That's insane.
Now, imagine telling a hiring manager in an interview, I can reduce your ETL runtime by 90% simply by understanding how to structure the query to leverage the platform's architecture.
That is how you get hired.
That's how you stand out.
That is incredible. But okay, speed isn't just about ingestion. Once the data is in, we have to transform it. And sometimes we have logic that just doesn't fold.
Folding, yes. We need to define that quickly for everyone.
Good idea.
Query folding is the magic that happens when Power Query is smart enough to translate your clicks into the native language of the source. Like, you filter rows on a SQL table, and Power Query sends a where clause back to the SQL server.
So it pushes the work back to the source, which is super efficient.
The most efficient, but not everything folds.
Right. What's an example of something that breaks folding?
A complex custom column you write in M. Some weird text parsing logic.
Yep.
Or maybe a filter based on a custom function that SQL Server has no idea how to interpret.
And historically, in Power BI and other tools, when folding breaks, the engine has to pull all the data into its own memory to do the processing.
Which is slow and very, very expensive in terms of resources.
Yeah.
This is where a new feature called the Modern Evaluator comes into play.
The Modern Evaluator. It sounds like a character from a dystopian novel. The evaluator is watching your queries.
It's actually the hero of our story here. The Modern Evaluator is a completely new execution path inside Fabric, designed specifically for these non-foldable or partially foldable scenarios.
So it's a better fallback plan. When folding breaks, this kicks in.
Exactly. Instead of choking on the data, it has a much more optimized way to read and write to the lakehouse in chunks. It's built for large volumes.
And what's the performance gain on that?
In that same NYC taxi benchmark, just enabling a Modern Evaluator for the transformation part improved the speed by about 1.6x.
Okay, so not the 9x of fast copy, but still a significant bump.
It's a very solid improvement for complex logic. But there was another term in the notes that sounded even more powerful.
Partitioned compute.
Yes. This is for the heavyweights. Partition compute is designed for a very specific, but very common enterprise scenario. Yeah. When your source isn't one big database table, but dozens or hundreds of individual files.
Like 56 separate Parquet files sitting in a data lake, each one representing a month of sales data.
A perfect example. Standard processing would read file 1, then finish, then read file 2, then finish, then file...
It's serial processing, one at a time. It's slow.
Very slow. Partition compute looks at that and says, wait a minute, I'm a distributed cluster. I have multiple cores. I can do better.
So it parallelizes the work.
It spins up parallel processes to read file 1, file 2, and file 3 all at the same time. It treats the files as natural partitions.
And the benchmark here is the real showstopper.
Well, this is the one you write down. Just using partition compute on that multi-file taxi dataset made the process 15 times faster.
15 times? That's massive.
Well, wait, it gets better.
Of course it does.
When they combined partition compute with the Modern Evaluator,
Don't tell me.
they took a process that was taking 1 hour and 44 minutes,
Okay.
and they brought it down to 4 minutes and 48 seconds.
1 hour, 44. Down to under 5 minutes. My math isn't that fast, but
That's 22 times faster.
22.
That is the power of architecture. It's the same data,
Yeah.
the same end result. But by pulling the right levers, fast copy for ingestion, partition compute, and the Modern Evaluator for transformation, you turn an overnight batch job into a coffee break job.
That is the interview answer right there. That's the mic drop. When the architect asks, my data flow is taking too long to refresh, what do I do?
You don't just say, optimize the code.
No, you ask, is the source a single table or multiple files? Are we using fast copy for ingestion? Can we enable partition compute for the transformation?
Exactly. You're demonstrating that you understand the mechanics of the platform, not just the interface.
Let's shift gears. We've moved the data, we've transformed it at lightning speed. Now we need to land it somewhere. The destination.
The landing zone. In Fabric Dataflow Gen 2, your main options are Azure SQL, Custo, which is Azure Data Explorer, and of course, the Fabric Lakehouse or the Fabric Warehouse.
Right, but there's a setting here that trips people up constantly. I've seen it happen. The difference between managed versus manual destination settings.
This is the classic battle between control and convenience. When you use the default, which is managed settings, Fabric basically says, don't worry about it. I'll handle the column mapping. I'll figure out the data types. I've got this.
That sounds great for a developer. Less work for me. You take the wheel, Fabric.
It is great until it isn't. The problem is that managed settings often default to an update method of replace.
Replace, meaning?
Meaning every single time the data flow runs, it drops the entire destination table and recreates it from scratch.
Okay, so I get a fresh, clean table every time. What's the problem with that?
The problem is a little thing called schema drift and all of its downstream consequences.
Schema drift. It sounds like a geological event, an earthquake for your data model.
It feels like an earthquake when it hits your reports on a Monday morning. Imagine you have a critical Power BI report built on top of that table.
Okay.
You have DAX measures, you have relationships to other tables, all linked to very specific column IDs and names. If you use dynamic schema, which is the setting that allows the table to be dropped and recreated if a source column changes, you can break all of those downstream dependencies.
So my report just, it stops working. It goes blank.
It goes blank. Or it throws 1,000 angry red error messages because the underlying object ID of the table changed or a column name shifted slightly, and Power BI has no idea what you're talking about anymore.
So how do we prevent this catastrophe?
You use fixed schema. This is actually the required setting if you're writing to a Fabric warehouse destination, and for good reason.
And fixed schema means what exactly?
It means you are making a promise. I promise the structure of this destination table will not change. The data flow will only replace the rows inside the table, never the table definition itself.
So if I go back into my data flow and change a column name from sales amount to sales amount,
The refresh will fail.
and that's a good thing.
That's a great thing. You want it to fail early, at the source of the change, rather than succeeding and silently breaking your CEO's favorite dashboard.
Speaking of failing early, there's a specific, very technical error that I want to drill into. It was in our research notes as error E104100.
Ah, yes. The infamous nullable error. This one is a classic rite of passage. We can't insert null data into a non-nullable column.
Let's role play this for the listener. I'm a junior dev. It's Friday afternoon, of course.
Of course.
My data flow has been running perfectly fine for a month. Suddenly, I get a frantic email. The daily refresh failed. I look at the logs and I see error E104100. What on earth happened?
Okay, here's the crime scene. A month ago, when you first built the data flow, Power Query did what it always does. It sampled your source data. It looked at the first 1,000 rows of a column called, say, customer name.
And it saw a name in every single one of those first 1,000 rows.
Exactly. So it made an assumption. It said, aha, this column is clearly non-nullable. You will always have data. It was being optimistic.
So it set the destination table schema to not null for that column.
It did. But today, a month later, deep in your source system, a new customer signed up and didn't provide a name. Or a glitch in the upstream application sent a null value through.
And the data flow happily picks up that new row with the null and tries to shove it into the not null column in the destination.
And the database destination, the warehouse, does its job. It says, access denied, you promised me no nulls.
Yeah.
Boom. Error, E104100 odor.
So how do I fix it? And please don't say the answer is delete the table and start over.
You can't just fix it in the visual editor sometimes, because the visual editor is still looking at the sample data and thinking everything is fine. You have to go to the matrix.
I have to open the advanced editor.
You have to open the advanced editor and look at the M code.
So I have to actually write code.
You have to tweak one little thing. You'll find a step in the M code called table.transform column types. You'll see the type for your column defined as, say, in64.type or type text.
Right.
You need to manually change that to type nullable in64.type or type nullable text.
You're explicitly telling the engine, look, I know you think this data is perfect based on your sample, but trust me, nulls are coming. Be prepared.
Exactly. And mentioning that specific fix, I had to go into the M code and wrap the data type in nullable, is such a specific battle-scarred detail. If you say that in an interview, the architect knows you've actually wrestled with this tool in the real world.
I love that. Let's talk about growth. We've been talking about moving data, but data grows. Data sets get bigger every day. Eventually, reloading the whole table every day, even with cast copy, is too slow and wasteful. We need incremental refresh.
Incremental refresh is mandatory for any serious enterprise solution. You simply cannot reload 10 years of sales history every single night just to get today's new sales. It doesn't scale.
The concept is simple enough. only refresh the data that has changed. But the setup in Dataflow Gen 2 has some very specific quirks and prerequisites.
First and foremost, query folding is non-negotiable here.
It has to fold.
It has to. If your query doesn't fold to the source, incremental refresh won't work efficiently. The engine must be able to send a query to the source database saying, give me only the rows where the order date is greater than yesterday.
If it can't do that, it just pulls everything anyway and filters in memory, and you've solved nothing.
You solved nothing and you made it more complicated. So query folding and a date-time column are absolute must-haves.
Okay.
Then you have the bucket configuration. Fabric makes you divide your historical data into time buckets: year, quarter, month, day.
How do I choose the right bucket size? Is smaller always better?
It's a classic trade-off. Small buckets like days mean each individual chunk of data is very small, so each partition process is really fast. But you might have thousands of these little buckets to manage, which creates its own overhead. Large buckets like years mean you have very few partitions to manage, but if you have to refresh a whole year's worth of data just because one record from January changed, that takes a lot longer.
Now, there's a really important difference here from Dataflow Gen 1, right? Regarding how historical data is handled.
Yes, and this is a gotcha that will bite you if you're not careful. In Gen 1, you could configure it to automatically remove data that fell outside your retention window. You could say, only keep the last 5 years of data.
And it would delete the 6th year.
In Gen 2, it does not delete old data from the destination. It only manages the refresh window. It assumes the history you've loaded is sacred and should be kept forever.
So if I want to purge old data for compliance or cost reasons, I need a completely separate process to do that.
You do. It's a crucial distinction. There's also a limitation, specifically when you're writing to the lakehouse, that caught my eye. It's about concurrency.
The fine print.
This is the fine print. The lakehouse, as a destination for this, allows a maximum of 10 concurrent evaluations.
So if I have a massive incremental refresh that tries to update, say, 50 monthly buckets all at the same time,
it will throttle. It'll queue them up and run them 10 at a time. That's a performance consideration. But the bigger risk, the one that causes failures, is writer conflict.
Writer conflict? What do you mean?
Okay, imagine your data flow is chugging along, trying to incrementally refresh the sales delta table. At the exact same time, you have a data scientist running a Spark notebook that is also trying to write to that same sales table.
Or maybe an automated maintenance job kicks off to run an optimize command on the table?
2 writers, 1 table.
Correct.
It's a recipe for failure. Delta Lake is good at handling concurrency, but Dataflow Gen 2 has some specific locking mechanisms. If you have other processes interfering with the table while it's refreshing, you are going to see failures. Orchestration is key. Don't schedule your maintenance tasks during your main ETL window.
This brings us beautifully to the topic that every manager, and definitely every solution architect, cares about the most. Pricing.
Yeah,
The silent killer of otherwise great projects.
it really is.
So how do we explain the cost model to an architect? Because saying it costs $5 isn't the answer they're looking for. They want to know how it's calculated.
You need to speak their language. And
Yeah.
that language is fabric capacity units, or CUs. And you have to break down the cost by the engine, just like we did at the start of our conversation.
Okay, so let's recall. We have the mashup engine for standard compute and the SQL engine for high scale. How does the mashup engine bill me?
This is fascinating, and it's not straightforward. If you have CI/CD enabled on your workspace, which you absolutely should, it uses a tiered billing model. For the first 10 minutes of a query execution,
The first 10.
you are billed at a high rate of 12 CUs per second.
12 CUs a second. That's the burst rate to get things done quickly.
Right. It's like a taximeter that starts high to cover the initial cost.
Yeah.
But if your query runs for longer than 10 minutes, the rate drops dramatically. It goes all the way down to 1.5 CUs per second for the remaining time.
That's a little weird. It almost seems to incentivize long-running jobs.
It's designed to give you burst power for short jobs, but to not bankrupt you if you have a genuinely long-running complex transformation. It's a form of auto-scaling logic.
Okay. But what if I don't have CI/CD enabled? If I'm just in a standard everyday workspace?
Then it's a flat rate, a punishingly flat rate of 16 CUs per second.
Ouch. 16 CUs flat. So just enabling CI/CD on the workspace effectively gives you a massive discount on compute.
Huge discount. That's a key takeaway. Always enable CI/CD.
What about the high-scale SQL engine, the one we use for the staged data?
That's simpler. It's built in a consistent 6 CUs per second. But remember, that meter is only running when the SQL engine is actually churning through your transformation query.
And fast copy, the Ferrari engine for ingestion.
Here is the best part. This is the kicker. Data movement is cheap. Fast copy is billed at only 1.5 CUs per second.
Wait, really? The fastest method is also the cheapest rate?
By far. Because not only is the rate the lowest at 1.5 CUs, but it also finishes in a fraction of the time, so you're consuming fewer seconds. It's a double win.
That is the ultimate argument for using fast copy. It's not just about speed, it's about budget. I use the split query pattern with fast copy to save the company money.
That's music to a manager's ears. It shows you're thinking about the whole picture.
But there is a hidden cost, a ghost in the machine, the VNet data gateway.
Ah, the gateway tax, yes. If you're in an enterprise, chances are you're connecting to on-premise data like an old SQL server in the basement or a cloud resource that's locked down behind a firewall. To do that, you need a VNet data gateway.
And that costs money just to exist.
It burns 4 CUs per hour just for being turned on.
Even if no data is flowing through it, even if it's 3 a.m. on a Sunday and no one is working.
If the gateway is on, it is billing, 247. And that can really add up. So the total bill for your solution isn't just the Dataflow consumption, it's Dataflow consumption plus gateway infrastructure cost.
You have to factor that into your whole ROI calculation.
Absolutely, you have to.
Now, speaking of gateways, that leads us directly into what you called the architect's nightmare.
Networking.
And specifically, one magical, troublesome number, port 1433.
This one issue is the cause of probably 50% of all support tickets in new enterprise deployments of Fabric. I'm not even exaggerating.
Okay, walk us through the scenario. Paint the picture of pain.
All right. You are a good developer. You build a data flow using our split query pattern. The first query ingests data and writes it to the staging lakehouse. Everything looks green, the lightning bolt is there, you feel great.
I'm hero.
You're a hero. Then you create your second query that references that stage data to do a transformation. You hit refresh.
Yeah.
It fails, but it's a really weird, confusing failure. The message in the UI might say table refresh succeeded, but the overall activity status has failed. And if you dig deep into the error logs, you see a vague network timeout error.
But why? It's all in the cloud, isn't it? It's Fabric talking to Fabric. Why is there a network error inside Microsoft's own cloud?
Because of the protocols being used. When you write data to the lakehouse, when fast copy is running, Fabric uses HTTPS. That's port 443. Standard, secure web traffic. Every corporate firewall in the world allows that by default.
Okay, easy. No problem there.
But when you need to read from that staging lakehouse, specifically when the SQL engine needs to query it for your second transformation query, it doesn't use HTTPS. It uses the TDS protocol, tabular data stream.
That's the native SQL Server protocol.
Exactly. And TDS runs on TCP port 1433.
And let me guess, enterprise security teams hate port 1433 with a passion.
They despise it. They block it by default everywhere because historically it's been a vector for database attacks.
Yeah.
So your Dataflow engine is trying to phone home to the staging lakehouse on port 1433, and the corporate firewall is slamming the door shut.
So you have a port 1433 issue. What is the fix?
The fix is often political, not technical. You have to go cap in hand to your network security team and ask them to update the firewall rules on the gateway or the proxy server.
Good luck with that conversation.
Right. You need to be very specific. You have to ask them to allow outbound traffic to 2 specific Microsoft domains, .datawarehouse.pb.dedicated.windows.net and .dfs.fabric.microsoft.com, but only on port 1433.
And if they say no, if the CISO says absolutely not, we don't open that port for anything.
Then you have a workaround, but it's an ugly one. You have to go back to your beautiful optimized data flow, and you have to disable staging on the reference query. Or you have to combine your queries back into one giant monolithic block of code so you never have to read back from the lakehouse during the execution.
But that completely defeats the purpose of the split query optimization we just spent 20 minutes talking about.
It does. It destroys the performance optimization. You're back to the slow in-memory mashup engine. But sometimes security policy trumps performance. And knowing that trade-off, I can optimize this by 9x, but only if we can get port 1433 opened, is what makes you an architect, not just a developer.
That is deep. Okay, we are coming into the home stretch here. We have designed and built the data flow, we've optimized it with fast copy, we've secured the schema, calculated the cost, and fought the firewall. Now we need to automate it, to make it part of a process.
Orchestration. A data flow on its own is an island. A Fabric pipeline is the bridge to the mainland.
Rajan showed this in his demo. wrapping the data flow activity inside a Fabric pipeline.
This is essential because data flows themselves don't have native alerting or complex dependency chains. If a data flow fails in the middle of the night, it just sits there, failed. But a pipeline can say, if the data flow activity fails, then send an email to the support team or send a message to a Teams channel.
It adds that layer of enterprise-grade control.
It does. But for the real power users, the infrastructure is code crowd. We have to talk about the public APIs.
This is where you really impress the interviewer who has a software engineering background.
Absolutely. Fabric has released a robust set of REST APIs for Dataflow Gen 2. You can use code to create, read, update, and delete data flows programmatically.
So I don't have to click the publish button in the GUI like a peasant. I can have a DevOps pipeline do it for me.
You can. You can trigger a POST request to jobsinstances.jobTypePublish to handle your deployment. You can trigger a refresh on demand with a similar call. You can even grab the entire JSON definition of the data flow itself and store it in a Git repository for version control.
That sounds like proper modern software engineering applied to data.
It is. It's a huge step forward.
Yeah.
But there is one significant limitation currently, and you need to know this. It's about authentication.
But there is always a catch.
Right now, as of our recording, Service Principal Authentication is not supported for these specific lifecycle management APIs.
Wait, so I can't use a bot account or a managed identity to run these scripts?
Not easily. You have to use delegated user tokens, usually acquired via a library like msal.net or through the portal. It means the script is effectively running as you, as a named user, not as an unattended system account.
That's a temporary pain point for anyone trying to build a true, fully automated CI/CD pipeline.
It is.
Yeah.
And Microsoft knows it. But just knowing that limitation, being able to speak to it, shows you've read the documentation closely and you're aware of the current state of the platform.
We have covered a massive amount of ground today. We really went from a simple Hello World demo to full-blown, in-the-weeds enterprise architecture.
Let's try to summarize it. Let's create a cheat sheet for you, for the listener, for when you're sitting in that interview chair, sweating a little, and the architect leans forward and asks, so tell me how you would build a scalable and performant data flow in Fabric.
Okay, let's count them down. Point number 1.
Ingest fast. You immediately talk about the split query pattern. You say, I'd use fast copy to get the raw data into staging as quickly and cheaply as possible, and then use the high-scale SQL compute engine to do the transformations. Mention the 90% speed improvement.
Perfect. Point number 2.
Transform smart. You discuss the modern evaluator for any non-foldable queries, and if the source is multi-file, you bring up partition compute, and then you drop that 22x faster benchmark statistic.
Nice. Point 3.
Staged correctly. You explain that you understand the data flow staging artifacts are the critical engine room and must never be deleted manually. You also discuss the importance of using a fixed schema for your destination to prevent downstream schema drift and broken reports.
Point 4.
Manage costs. You show you understand the capacity unit model. You explain that enabling CI/CD on the workspace gets you cheaper burstable rates and that fast copy is not only the fastest but also the cheapest way to move data. And don't forget to mention the gateway tax for on-prem connectivity.
And the final one, point number 5.
Secure the network. You become the person who proactively asks about port 1433 before the project even starts. You show that you anticipate firewall issues and understand the trade-offs between optimal performance and network security policies.
If you can articulate those 5 points clearly with the details we've discussed, you aren't just a fresh graduate answering questions anymore. You're a peer having an architectural discussion.
Absolutely. You shift the entire dynamic of the conversation from can you code to how should we build this system together.
I want to leave our listeners with one final thought, something to chew on that we haven't explicitly covered, but feels like the logical next step from all of this.
We've talked a lot about the technology, the how, but I want you to think for a minute about the philosophy, the what. We are seeing a fundamental shift in the industry from building a data flow, which implies a script, a task, a one-off thing, to managing a data product.
What does that distinction really mean for the day-to-day work of a data engineer or a data scientist?
Well, think about it. With features like incremental refresh, CI/CD integration through APIs, specific pricing tiers that you have to manage, a data flow is no longer just an ad hoc ETL script you wrote in an afternoon to solve one problem.
No.
It's a robust, living piece of infrastructure. It has a life cycle. It costs real money to run every single day. People depend on it. It has service level agreements or SLAs, whether they're written down or not.
So the question that leaves us with is, how does this change the way we verify our work? In software engineering, we treat Python code with strict Git standards, automated unit tests, and mandatory peer reviews. How do you unit test a GUI-based data flow? How do you effectively code review a series of click-and-drag interface steps?
That is the new frontier. The tools are becoming incredibly powerful, but our development processes and our discipline need to catch up. And if you can ask that question in your interview, I'm really interested in how your team handles version control and automated testing for Dataflow logic to ensure it's treated like a first-class data product. You might just stump the architect.
And sometimes stumping the interviewer with a really smart, forward-thinking question is the best way to get the job.
Just, be nice about it.
A huge thank you again to Rajan for the inspiration and the demo that really started this whole journey, and to you, the listener, for sticking with us on this very deep dive.
Good luck with that interview. Go get that job.
We'll see you on the next deep dive.